Good morning. Good to see you here today on our first online maths lesson on volume. I'm very happy that you're able to make it here this morning. And even though we have got very difficult times, but we're looking forward to a better future. So the first thing I would like you to do with these questions on the slide, based on 5 skills that I want you to try to remember. These are things you would have done last term, previous term, or even last year. So I'm going to give you 5 minutes to go over them. 5 minutes to go over. We've got less than 1 minute now. Okay, so let's check the answers. Get your green pen out, and we can check the answer. So you can see the vertical difference there is the 10 take away 4, which is 6, and the horizontal difference is the 4 take away 2, which is 2. So you use Pythagoras squaring both numbers, 6 and 2, adding them together to give you 6.3 once you have found the square root. The second question says the graphs they have a point of intersection, which means at that point, the two graphs are the same. So you equate them together and you work out for the S. The x-axis, so you can substitute into any one of the equation, either the y equals x plus 3 or y equals 3x minus 9. You work it out and you find out that y is 9. So the coordinate that we are looking for is bracket 6, 9, close brackets. This other question here, the percentage that was in July is 100%. So after an increase of 40% in August, we now have 140, and the decimal changing it will be 1.4. So the question percentage decrease, so percentage change is always the change divided by the original times 100%. So in this case, the change here is 0.4. And the original from August to September, when it was in August, it was 1.4. So the percentage is 28.6% in 1 decimal place, or 28.57, 2 decimal places. The question on trapezium, you need to identify the parallel sides first. So in this case, you can see it's a 10 and an 8. So you add them together, that's finding the mean, and then you multiply by the height of the trapezium, and that gives you 63%. For the recurring decimals to fractions, I'm actually going to change to another screen so that you can see how I did it. So 0.84 to fraction. So we say let the fraction be 0.848484. Because there's two numbers recurring, you have to multiply both sides by 100. So you get 100f and 84.848484. Now you now have two simultaneous equations, these two simultaneous equations, which you can then solve by subtracting equation 1 from equation 2. That leaves you with a 99f equals 84. So f will be 84 over 99. You must make sure that your fraction is simplified. So big fraction, we have a 3 that is a factor between the numerator and the denominator. So we use it to cancel out, and we have the final fraction to be 28 over 33. So we have changed 0.84 to fraction in its lowest term. The next question is this one, where we have to change 0.45 into a fraction. You can see it's only the 5 that is recurring, the 4 is not recurring. And so when one number is recurring, we have to multiply by 10. And that gives us 10f is equal to 4.5. And again, solving the simultaneous equations, we will subtract equation 1 from equation 2, and we have now 9f is equal to 4.1. Okay, so we now solve for f. So that's going to be 4.1 divided by 9. This doesn't look right because you got a decimal in a fraction, part of a fraction. So we need to multiply the numerator and the denominator by 10 in order to get the simpler fraction. Okay, so the next one. So the skills that we learned today are the coordinates and Pythagoras, point of intersection of straight lines, percentages, recurring decimals to fractions, and area of trapezium. You may want to go and study or revisit these topics at your independent study time. So for this lesson volume, we will need to check again some skills that you should know before we start the topic. So we should be able to find the volume of prisms, area of circles, Pythagoras. You apply Pythagoras to find missing sides of a right angle triangle. You should be confidently be able to express length, area, volume algebraically, especially when you have a worded problem or problems, very hard problems to do. You should be able to substitute into expressions and formulas, especially substituting into formulas, because that's what we really need for volume of 3D shapes. Okay, so to test your knowledge and for us to remember all these particular 3 skills, I would like you to do these questions, and I'm going to give you 5 minutes for you to do them. Think about what it means to find a solid that holds the most water. It could be water, it could be any liquid, anything. You know, which one holds the most and what does that mean? should have been able to do the questions. Okay, so let's see the answers. That's for the first one. And to hold any stuff that is liquid, that's the biggest volume. That's what you're asking you to find, the biggest volume. So for the cylinder, the area of the cross section is the area of a circle pi r squared, and the height, the length is a 6 centimeter. You should be able to find any prism by finding the area of the cross section and multiplying it by the length of the prism. So the diameter here is 3 centimeter, so that is going to be 1.5 for the radius square times the area. And then the answer 7.0685834 we multiply by 6 to get 42.4 centimeter cube for the volume. For this one, the volume is the area of the cross section, which is 3 times 3, that's a square, multiplied by the length of the prism, which is the 6. So we get 72 centimeter cube. For this one, the area is the 4 times 4, which is 16, multiplied by the height, which is 64 centimeter cube. So the solid that has got the biggest volume is the cuboid, which is 72 centimeter cube. Okay, in this question, for this first triangle, we are looking for the hypotenuse, which is the longest side. And so to get it, we square both sides that we are given. We know we have to apply Pythagoras because we have been given a right angle triangle with two sides given, and we're looking for the longest side. Same here, 2 sides given, which includes the hypotenuse, and we are looking for the other side. So for this one, we're going to square both, then subtract, then find square root. So I'm going to show you how we just worked it out. So the first one, the hypotenuse x is 8.9, and the second one, the other side we were given is we're asked to find is 9.7 centimeter. The substitution into a formula, all we need to do substitution is like when you play football, you substitute. That means someone replaces another person. In this case, we are replacing a letter with the number that we are given. And then we work out to get the final answer. In this case, 5 times 3 squared, 5 times 9, which is 45. There are no units given, so we leave it as that. So hopefully, now that you have practiced, you'll be able to apply these skills into what we are going to be doing next. So last week, we all did surface area. Remembered the surface area for volume for a sphere, and the volume is 4/3 pi r cube. Remember the surface area for a cylinder, 2 pi r squared, means the 2 lots of the area of the circle for the top and the base. And the curved surface area for a cone, which is the pi rl, and the volume of a cylinder is area of the cross section, which is a circle, times the height, and the volume of a cone, 1/3 pi r squared times the height, and the volume of a pyramid, 1/3 the base area times the height. This applies to any pyramid. Okay, for example, the tetrahedron, which is this triangular base pyramid, or any pyramid with an irregular base. Okay, so you must learn this because these are no longer being given on the exam paper, no formula sheet. So you need to learn it. I'm going to give you a moment to take out your phone now and take a picture of this slide. Okay, so we're going to move on now, concentrating on the volume of these 3D shapes. Okay, so the volume of a pyramid is 1/3 of the area of the base times the vertical height. Remember, it's always the vertical height. And the cone is same, 1/3 base area times the vertical height. The sphere is different, it's 4/3 pi r cube. Again, I'm going to give you time to take a picture of this. Okay, let's move on. So we have these 3D shapes that we have to find the volume. Okay, just a quick reminder, in case you are not able to take the picture, then you have it here now. So we're going to do these three with you. We're going to work out the volume together. And then after that, get ready because you're going to be doing some by yourself. Okay, so we start with the sphere, where the volume, remind ourselves, is 4/3 pi r cube, and the radius is 3. This is a simple case of substituting into the formula, and we substitute properly, you get a 1 mark in an exam, and we get 36 pi in terms of pi. Really, sometimes you're asked to write and leave your answer in terms of pi. This is exactly what that means. So you don't go further than this, trying to use a calculator, you just leave it like this. But if it does say, write your answer to 1 decimal place or something like that, then in that case, please do ST button and find out the final answer to 1 decimal place. Okay, let's look at the square-based pyramid. Again, remember the formula is 1/3 of the base area times the height. So in this case, you can see that the base area, we're looking for the area, the square, which is 6 by 6. 6 times 6 is 36 centimeters squared. Always remember to put the unit after any answer. And we put it in the formula. So we're looking for 1/3 of 36 times 5.2, and we get 62.4 centimeter cube. This can be used for tetrahedron, like I said before, or any pyramid with an irregular base, as well as the cone. Okay, I hope you're getting them now, because we're approaching you being able to do a few by yourself. Look at this, is a cone, and the volume is just the same as we find the volume of the pyramid. But there's something a bit, might bring a bit of confusion. The two sides, the 9 centimeter, and what is supposed to be the height. So we're going to have a look at this and see. Remind ourselves the formula again, 1/3 of the base times the height. So the base is the circle, the diameter is 8, so that means the radius is 4 centimeters. So we find that and we get 50.27, that should be centimeters squared. Now we are going to go and find the volume. Should we use 8.1 or shall we use the 9? Remember, the height is the distance that meets the base at 90 degrees. Looking at this, the 9 centimeter slanting line length does not, whereas the 8.1 meets the base at 90 degrees, so the height is 8.1. Substitute into the formula like this, and then you get a final answer there. So now it's your turn to complete these 3 questions, and I'm going to give you, for these 3 questions, I'm going to give you 6 minutes. Remember to add the units to your answer and show you're working out very clearly. Now I've got 2 minutes. Okay, so the time is up now, and I'm going to show you the answers to this so you can mark your work. Okay, so for the square base pyramid, this is the answer for the area. And then to find the volume, we do 1/3 of that area times the height. That gives us 6.7 centimeter cube. For the cone, 1/3 of pi r squared times the height. So we work it out, 47.1 centimeter cube. And for the sphere, the radius is 3, so that will be 4 pi r cube. And we work out the answer, 113.1 centimeter cube. Okay, check your answers and mark it. I'm sure you're feeling much more confident now about substituting into the formula for a volume of any solid. Once you remember it, then you just substitute. So to help us remember, maybe we write them on make flashcards, and put the flashcards on our table, by the kitchen, in our room, everywhere, so that the more we see it, and not just putting it there, we also find questions on study guide question, revision guide questions, Mass Watch and Hegeti to do. Okay, so these 6 questions are for you to do. I'm going to give you 10 minutes for you to complete these 6 questions. Please be careful about the third solid on the first row. You've been given the slanting side, 12.6. So please, I'm very interested to see how you're going to tackle that question. Also, the middle question, the hemisphere on the second row. Okay, please pay attention. Make sure you understand what to do about that question. And finally, the last question on the second row on the right, that question is actually a cone that is sitting on a hemisphere. The height of the cone all the way down to the bottom of the hemisphere is 22 centimeters. Okay, so you should start, and you have 10 minutes to complete this. You have got 4 minutes 51 seconds. Make a sketch of the questions as well. It will help for revision. You have got 3 minutes and 20 seconds. Try as much as possible, especially the cone on the first row at the end, and the hemisphere, also the last shape in the second row on the left. It's a cone sitting on a hemisphere, and the height altogether is 22 centimeters. Okay, to see what you did to those 3 questions. Okay, so time is up now. So let's check the answers. We're going to go through them one by one. Okay, so get your green pen out and get ready. I do hope you were able to attempt the 6 questions. So the cone. So that's the cone. So we say 1/3 base times the height, and we multiply it by the height, and then we get the final answer, 209 centimeter cube. Okay, did you get it? If not, copy down the correction. Okay, the next one is this one. The height is 12 and the base is 10. Also, that's the diameter. The base diameter is 10. So we need the radius by dividing that 2 into 2. So we get the radius is 5. We substitute into the formula and we get 315 centimeter cube. The third one, that's the one I'm interested to see what you did. So looking at this, you can see that there's a little triangle, right angle triangle there. This is the slanting length. That's the radius of the circle, that is the cross section. And then we are looking for the height because we need the height to work out the volume of the cone. Says the volume is 1/3 the base times the height. Where is the height? So we need to find the height first by applying Pythagoras theorem onto the triangle. So the hypotenuse is 12.6. The height is going to be follow 12.6 squared minus 5.7 squared, and the answer we get, we subtract square root. I've already reminded you here about it. So we square the two sides, subtract, and then find square root. So that gives us the answer, which is 11.2369. So now we can use it to find the volume. So the volume is 1/3 by 5.7 squared times h. And the h we've already found, so we substitute and get our final answer. Remember to add the unit, centimeter cube. So we have 382.3 centimeter cube. Okay, the next one is the square base pyramid, where we look at the 1/3 times the base times the height. So 9 times 9 squared times 9, and that leaves us with this as the volume of the square base pyramid. This is a hemisphere. The hemisphere is half of a sphere. If we're asked to find the volume, first we find the volume of the sphere, because it's going to be the same radius. And then we get the answer. We have to divide this by 2 to find the volume of the hemisphere. So this is the last one, where we have the cone that is sitting on the hemisphere. So first thing we need to do, we find the volume of the cone, which is 1/3 base area times the height. Notice that the height is from the top of the cone to the base, to the bottom of the hemisphere, is 22. So what is the height of the triangle? So we need to take away the 7 centimeter, because wood here is also 7 centimeter, 7 centimeter, 7 centimeter. So we need to find the 22 minus 7, which will be the 15 for the height of the cone. We substitute and we get the answer, 769.69 centimeter cube. Now we need to find the volume of the hemisphere, and that will be, find the volume of the sphere first, divide the answer by 2, and then that will give us finally the total volume for this whole shape is the volume for the cone plus the volume of the hemisphere, which gives us 1,488.06752 centimeter cube. We were not asked to round it, so we leave the answer like that. Actually, we might want to round it up to, because we might want to round that up now to nearest whole number, and that's what we will get, or nearest 10, or whichever one. In this case here, that's 140 to, sorry, that went back, 1,490 centimeter cube. Okay, so next one. So do you remember, these are the formulas that we use. We need to try to remember them, and you can only remember them if you are constantly practicing and during your study time, you know, you are doing questions on this, you're making flashcards and pasting it on your table where you can remember. So we're going to look at problem solving questions to do with the volume, as this usually appears on, this is what is on the AO3 paper, problem solving questions. Have a look at this one, and I'm going to give you just 4 minutes to try this one out. Okay, so we are now going to look at each one of them one by one. The first one is the hemisphere. So the diameter is 8. So we need to work out the radius, which is half of that. And half of 8 is 4. So we work that out and we get 2, 6. But we need to divide this by 2 because it's a hemisphere. So the answer should be 134.04. And that's the correct answer. To one decimal place, it will be 134 centimeter cube. So this answer is not correct. For the second question, okay, we need to work out the volume of the cone. The volume of the cone is this because the 8 is the radius. We substitute, we work out, and that's it. We already know that 100 centimeter cube is 1 liter. So to change from centiliter cube to liter, which is the biggest measure, we will need to divide by the conversion factor 1000. So 1474.5 centimeter cube is 1.4 liters. So I'm leaving it for some time so that you can make your people that are making their corrections. Okay, we're going to move on to the last one. For this last one here, we haven't been given any measurement actually. What we've been told is that the cone and the hemisphere have got the same volume and the same radius. And we should find the height of the cone in terms of R. So finding a variable in terms of another means we have to do H is equal to something to do with the R. Okay, so we said the volume is the same. So maybe volume is the same, the radius is the same. So the formulas must be the same. So we then have the 4 pi r cube for the hemisphere and the 1/3 pi r squared. Okay, so that is the volume of the hemisphere. And we need to the volume of the hemisphere, but we need to divide it by 2 later on. So then we calculate cancel the pi's. And then we cancel the r squareds. And then we have that. Actually, for this question, I wanted to say that the cone is between the cone and the sphere, not hemisphere, please. Is the cone and the sphere. So then we get divide, we get 4r is equal to h. So h equals 4r. So please note for that question, it's supposed to be a cone and a sphere, not hemisphere. Okay, finally, let's look at this. You're going to match each shape with the formula. So I'm going to give you 1 minute here to match the shapes with the formula to find the volume. Okay, so I'm giving you 1 minute. Okay, you should have been able to match the equations, match the formula with the shape, and we should get something like this. That's for this one is for the sphere, that is for the cone, and this one can either go anywhere, because both of them is 1/3 times the base times the height. Now on this side, which is a star question, just wanted to remind you to find the volume of the shape below. So I've got questions, and I'm going to pause for you to write down the answer, and then I reveal it. So that question is this. My first question is this. Sometimes you're asked to do, this might be a question on GCSE, but there are some hidden questions. Maybe they're not there, and that's what you have to ask yourself and be able to find a quick answer, give an answer to the question that they asked. So the hidden question here, or what you should do first, is ask yourself, what do you need to find first? You know that the volume of a cone is 1/3 the base area times the height. To find the base area, which is a circle, is pi r squared. You look, have you got the radius? Yes, it's 8. Present is there. Now you want to find times the h. Where is the height? It's not there. So what you are actually need to find is the height. Now, to find this height, if I put a line through where the height is supposed to be, from the apex to the middle of the base, we would have created a right angle triangle. So what skills are we going to apply to find this height? Put your answers down, and I will reveal. Okay, you should have written Pythagoras theorem. Okay, so today's lesson is about formula, using the formula for 3D shapes to find their volumes. And the key word there is substitution. And we had that question where we had to simplify or write expressions for length, area, or volume in an algebraic form. And then finally, just to remind us that sometimes we might need to apply other skills in order to find what we are being asked for. If you're able to do this in exam, you would have gained yourself the 5 marks or 6 marks at GCSE. So what I've got next slide is a couple of questions from past GCSE papers, the specimen questions. I would like you to try these questions at your independent straight after. It would be nice if you try it after this lesson. They are all GCSE questions, and I've managed to put for you also. You can see the marks, 3 marks, 2 marks, 3 marks, like that. You need to read these questions carefully. They are just like the past, the ones that we have done. Okay, read them carefully. Make sure you got all the dimensions that you need. The answers are on the second slide. Right. I do hope you got the answers, but do it first before you get to the answers. I do hope you have enjoyed this lesson today, and you can take away some of the skills that you have learned and apply it to problems that you will be given in an assessment, in a test, or a proper GCSE. I want you to stay safe and keep studying, and God bless you all. Bye for now.